Hi, this is Kevin Trainer. Welcome to my lecture on Chapter 10 of Interaction Design, 4th edition. Chapter 10 is entitled Establishing Requirements. Here's an overview of what we cover in the chapter. We're going to be talking about the importance of requirements, different types of requirements, data gathering for requirements, data analysis and presentation, task description as part of an expression of requirements, and we're going to cover 3 different ways to express requirements as task descriptions: scenarios, use cases, and essential use cases. And then we're going to cover task analysis, and in particular a methodology called HTA, or hierarchical task analysis. Okay, so I just want to point out that as we get to this chapter, we're going to find out that this book, the way of thinking about what we know and what we can learn and what information we can organize, it really operates on 2 levels, okay? You remember that we talked about data gathering already, and we talked about data analysis. And on one level, it has to do with, say, user studies, right? So we're going to have some kind of a product, and we're going to find some way to gather data about the usability of that information system product, interactive product. And then we're going to analyze it, and then we're going to find some way to act on that. And we had a whole methodology for that. But the other way in which this data gathering and data analysis point of view applies to us is that in order to really look at the usability of an information system or other interactive device, one has to understand what the requirements are. And how does one find out what the requirements are? Well, on a whole other level, we have to gather data and we have to analyze it. So here, when we're talking about gathering data and we're talking about analyzing it, we're not really talking about a particular information product that's already been created that we need to, or perhaps it's been prototyped, that we need to come to some conclusions about how usable we think it is, especially compared to some kind of alternative. We're earlier on in the process. We're trying to nail down what the requirements are, okay? And because it's our point of view in user-centered interaction design, that you can't really assess the usability of a particular information product without understanding what is being done in the workplace. What are the requirements for this product? In particular, who is the user? Or who are the users? What kind of job are they doing? In what kind of time context? In what kind of environment? What kind of capabilities and sensibilities do they have? All those kinds of things. So, requirements. That's how we got here. Okay? We want to ask ourselves about questions like what, how, and why. What needs to be achieved? We want to understand as much as possible about the users, the tasks that the users are trying to achieve, and the context in which they're trying to achieve that. And what we want to do is we want to produce a stable set of requirements, because our primary job is going to be in the next step. Our primary job is going to be to come up with a design that meets the requirements, that has the level of usability that we desire. Okay, and perhaps to come up with alternative designs like we talked about last week, that we can compare usability, prospective usability of alternatives. So how can we do that? Well, again, we've got data gathering activities, data analysis activities with regard to the requirements. We need some way to express the requirements. So we're going to talk about how do people typically express requirements for information systems and interactive products. And we want to remind you that this is an iterative process. Okay, we talked about our overall interaction design being iterative. And really the process of doing, say, systems analysis and design these days, I mean, there's a fairly prevalent point of view that says that it works well when it's iterative. So here's a cartoon that you may have already seen. Hopefully you read the chapter and you've already seen it there, but perhaps you've seen it before. And it's a humorous exploration of how we can get the requirements wrong, right? So how the customer explained it, how the project leader understood it, how the analyst designed it. That's kind of interesting. I guess the implication here is that the analyst wanted to create a great experience, but didn't worry too much about practicalities. How the programmer wrote it, that's kind of anti-programmerish. How the business consultant described it, comfy, I guess. How the project was documented, no documentation. What the operations people installed, just a rope, the bare minimum. How the customer was billed, it looks like an amusement park rides, that must have been built a lot. How it was supported, like a stump. I guess we don't give a lot of support to stumps. And what the customer really needed, a tire swing. Which, actually, if you look at the tire swing and if you look at what operations installed, they're not too different. The operations people were only off by one part. So perhaps the author, the cartoonist here, maybe comes from an operations kind of a background and feels like the operations people probably know most about what the users really need. Not everything, but they're well on their way. So clearly we can get it wrong, and so we ought to be trying to get it right. When we're establishing the requirements, and there's a nice kind of a discussion in the chapter about how we talk about requirements, whether they're things that we discover, or whether they're things that we, invent. And I'm not going to get onto that philosophical of a discussion here, but here we've got presented to us the dichotomy between what users want and what they need. And as we saw from the cartoon, a lot of times they're not the same thing. Our wants are often influenced by what we see other people having, or just particular worrisome things in the environment that cause us to maybe not see what our needs are completely clearly. So being able to distinguish between those two is important. So requirements need clarification, refinement, completion, and rescoping. So we just ought not take them as they're given to us. Okay? Probably don't want to say to a particular user or user group, what do you need? And then just write it down. But this requirements process, we're going to get some input that are going to come, perhaps, I'm hoping, from the users themselves. Okay. It might be, and again, we get back to what kind of activities do you do to collect data? Well, you might interview people individually in groups. You might do questionnaires. You might do observations. All those things that we talked about apply here. And what we want to get out of the process is that we want to get stable requirements, which I would call this. I think that we want an expression of the requirements that the various stakeholders can look at and come to consensus on. Okay, that's about as stable as the requirement is going to get. Could the stakeholders be misguided at that point? Sure, they could. That's why requirements have a tendency to change over the course of a project as we learn more. Okay, could the world change? Could we have the requirements right for now but wrong for later? Sure, they could. Okay, but given the way we see the world and given the way we understand our needs and our capabilities and our options and all that kind of stuff, a stable set of requirements is an expression of it's an expression of a combination of the needs of the users and the features of the solution and how they intersect with each other. And they're stable in that we have a way of expressing them and reviewing them, and we can get consensus on them. Why do we want to say that we're going to establish the requirements? Well, I think we want to be somewhat scientific here, right? We did talk a lot about data gathering and data analysis. We would like to get away from just kind of opinion, okay? And then we would like to, have some kind of understanding of the needs that we're able to justify and relate to data. Either, and again, how did we get the data? Well, we might have gotten it through interviews or questionnaires or observation, all those things we talked about. Several places in the chapter, you will find examples from a methodology called Valeri. At least that's how I would pronounce it and do. It's an Italian verb to want. So when we're talking about what the requirements are, we want to know what people want. So I think that volere is maybe a well-chosen word. This is a methodology that's probably less prevalent here in the US and more prevalent in the UK. If you click on the links to the methodology, if you go follow it up, you'll see that it's got probably a bigger following in the UK than here in the US. And of course, the authors have more of their background in the UK than we have in the US. But it's as a good methodology as any to serve as an example of how we might express our requirements. So let's say they number the requirements, they categorize them as to type, They are relating it to some kind of a use case or event. So we're going to be talking about use cases in a little bit. There's a description, a rationale, source, fit criterion, etc. Okay, so this is a requirement. This is requirement number 75. And as you can see, we can't, yeah, I guess we could probably fit this on a large index card. Right? Here's a larger part of the Valeri requirements template. Okay, and they've got all kinds of things: project drivers, project constraints, functional requirements, non-functional requirements, project issues, a lot of things. Okay, and what you realize here is, oh, this is this is a systems development methodology that's popular with the interaction design folks. Okay, and as part of it, we're going to document functional requirements as well as non-functional requirements, and this is pretty typically what people do when they're doing systems analysis. So in my systems analysis courses, I teach my students to do kind of the stuff that we see here, with an emphasis on eliciting and documenting the requirements. And I don't really follow this particular methodology, but this is certainly consistent with what I've taught over the years. So, what kind of requirements do we have? Well, people talk about three kinds. Some of us, like me, take the three and boil it down into two. But here, our authors want to tell us there are three kinds of requirements for a system: functional requirements, what the system should do; non-functional requirements, how it should perform; security, response time, usability is one of the biggest areas of non-functional requirements. Okay, so that's going to be a big area for us. And data. What kinds of data need to be stored? How will they be stored? Okay. Now, what I teach people systems analysis, I say that data requirements are just another expression of functional requirements. Because what does the system have to do? Well, it has to do stuff and it has to know stuff. And they're both, in my mind, functional requirements. One could argue otherwise, and certainly the authors do. Okay? So if you look at the responsibilities here, we're saying there are three kinds of responsibilities. To do, functional; to perform, non-functional; and to know, data. So we need to understand the requirements in terms of the context of use, because remember, you and I, in the context of this course, are not just systems analysts. We're interaction designers. Okay, so we're particularly interested in the interaction design. All right. Now, these questions from the slide before, which are the stuff of systems analysis, are of interest to us because these findings of systems analysis are what are going to drive our requirements, and without the requirements, we can't tell how usable a particular system is. So we need the requirements, plus we need to know things about the context. So what kind of things do we mean by environment or context? Well, we have the physical environment. Is it dusty, noisy, wet, hot, humid? Okay. Are there all those kinds of things? Not so much are there people, because that gets down to social. Um, Social. Are there people around? Okay. Um, some people might put this into physical, I guess. But are there people to look and see our work? And do we want them to or not want them to? If we're trying to share things, well, we want people to share things. If we're trying to keep them secure, then we don't want to. Right? So in the social sphere, sharing of files, displays, paper, over distances, synchronously or asynchronously, privacy issues, all those kinds of things. And then we have the organizational environment as well. So we have the hierarchy of the whole overall organization, who's responsible for what, who has what kind of power and control, what the IT department's attitude and remit are, and remit is sort of a British expression for um, charter. More typically, we would say that the IT department has a charter. They have these responsibilities that they've taken on. They're chartered to do a certain thing. In Brit speak, we'd call that their remit. What the user support's like, the communication structure, infrastructure, and the availability of training, and all kinds of things like that. So physical, social, organizational. Those are all very important environmental or a context of use considerations that are going to be our primary concern, because we're not just systems analysts, we're interaction designers. So I think there's a couple of boxes, or one continued box in the text, where we talk about a PC for underwater use, and then another device that we could use with the PC. And the PC for underwater use is called the wet PC, and there is an input device, more appropriately an input-output device, called a cord pad. Let's see. The cord pad is, I think, input. The virtual display, which is in the mask, is output. And the wet PC is processor. And here's the cord device. And as we can see, it has something for the index finger of the right hand, the index finger of the left hand. We have all these kind of buttons and such that allow us to provide input. The other property that this thing has, as I recall, is it has a GPS ability so that we can locate ourselves geographically. And of course, that's made more complex by the fact that we're underwater, and without special arrangements, it's very difficult to get satellite signals underwater. So this device probably has a companion device on the surface that allows it to get GPS coordinates from the sea bottom. As we could see there, it wasn't only information requirements or even the job requirements, the task requirements of that underwater stuff, but the environment that drove our design. Okay, so it was the collection of all those. It wasn't just one or the other. It was all of those together, collectively. It drove the design that to the devices that we saw for the underwater stuff. So, oh, what do we have to know? Well, we have to know who our users are. Okay. Um, Again, this is user-centered interaction design, right? So one of the first things we're going to ask is who the users are. So characteristics like what's their nationality, what's their educational background, what's their attitude toward computers. Um, we also want to know, do they have typical abilities? Do they have typical sight? Do they have typical hearing? Do they have typical manual dexterity? Do they have typical mobility? All those things would be of interest if we were doing the underwater stuff. In terms of system use, you really can't go wrong by reminding yourself over and over again in the distinction between levels of users. Here we're talking about novice, expert, casual, and frequent. And again, I point quite frequently to the Cooper material on levels of users, and Cooper's observation that with most products that have a voluntary use, that the novices don't stay novices long, because if they can't learn your product to a higher level, they usually abandon it. Um, People go from being a novice in the Cooper parlance to being an intermediate before they go on to being an expert. And people who go on to being experts don't stay expert forever, because quite frequently their use gets interrupted by other responsibilities and they revert to being an intermediate. So one of the observations that Cooper has that I really like a lot is this idea that we have these sort of perpetual intermediates. You get there's a real bias towards a big group of your users being intermediates. But the differences are going to be significant. Okay. If you're a novice, you want your choices prompted, constrained, and clear. If you're an expert, you want a flexibility and access to power. If you're a frequent user, you probably want shortcuts. If you are casual or infrequent, you probably want menu paths. Okay, so this ability to characterize your user on these kinds of axes are pretty important stuff. What are the user's capabilities? Well, again, I mentioned a couple of these things on the last when we were looking at the last slide, but what are their physical dimensions? The size of their hands could affect the size and the positioning of the buttons. Do we have just one size of device, or perhaps do we have a small, a medium, and a large? And do we have one that's good for left-handers and for right-handers, or do we have a model for each? We're going to have to know what is an appropriate height for something like a kiosk. we're going to have to take into mind, if we're designing a child's device, the strength that it's going to take to normally operate the device, but could we require greater strength to change the batteries? Well, yeah, we probably might want that because we don't want the batteries to get into little mouths, for instance. And here on this slide we talk about disabilities, but I think that we'll do better to talk about typical abilities and atypical abilities, because that's the more sensitive way to talk about these days. And so, do our people have a typical sight or atypical sight? Do they have a typical hearing or atypical hearing? And we're going to have to decide, what's our population and what we're going to want to and need to support. We talked about personas a couple of times. Here's where we get into more detail on personas. So personas are a very popular tool in interaction design, and it's a way for us to capture a set of user characteristics. It's a kind of user profile, and they're fictional, so they're not real people, okay? And usually they're a synthesis of several real people that we meet, okay? So what we want is we want to create a set of personas for that represent the users of our system, and we don't want to have, if we're going to have 25 real users, we don't want to have 25 personas. If we did, we could just simply describe the real people. We might want 2 or 3. We want to bring them to life with a name, characteristics, goals, and a persona, a background. And I think we've got a screenshot from the book here coming up, right? Yeah, we do. And what we really want to do is we want to fictionalize this in a realistic way such that it's easier to imagine who we're solving the problem for. Okay? And of course, as we trade off decisions along the design way, having the personas to go back to gives us a structure to hang our decisions on. We want to develop a small set of personas with one primary persona. So maybe 2 or 3, with one being the primary. And again, when we're thinking, we have a user population. It's diverse, okay? So we would probably want to have some idea. If we had 3 personas, we probably would want to have some ideas about the preponderance of each of the personas in our overall population. So here's an example of our persona. The persona has a name, Ginny. Ginny has a photo. She has a story. She also has some bullet points. There's her background, her motivations, her frustrations. She's got a whole write-up here, and we've even got some art to bring it to light. Bring it alive. Now, whether this art has to do with parts of the ways that Ginny's going to use the system, or whether the art has to do with making Ginny seem like a live person, I'll bet that the Abercrombie shirt is the latter rather than the former, and maybe the Ugg boots as well. So, data gathering for requirements. Well, again, we're going to use those data gathering approaches we talked about a couple of chapters ago. We're going to use them in two contexts. One is to make sure that somebody gathers the requirements. Now, that could be our primary responsibility, or it could be another person on the team. Perhaps we're working with a systems analyst, okay? But how does one gather the requirements? Well, one does interviews. We talked about those, okay? One could do focus groups. We talked about doing focus groups. They're the same focus groups we talked about before, okay? One could come up with questionnaires, right? Now, there are a couple things that they talk about within the chapter here that I don't think we talked about back on data gathering. One is we could research similar products, right? So when we're trying to come up with the requirements, rather than trying to understand the fit of a particular design to the requirements, well, then we probably might want to go look at similar products, competitor products, collaborators' products. We might want to do direct observation. Okay, we talked about doing that. We might want to do indirect observation, which would be not us observing the activity, but for instance, asking our users to be mindful of their activities and to journal them. We might want to study documentation, okay? So we might have user procedures. We might have all kinds of documents that we might find in the workplace that either describe current systems, current business practices, procedures, standards, any of those kinds of things. They could be useful. They could also be inaccurate. Okay, when I teach my systems analysts, I say that this looking at documentation is a big question mark, because I think there are kind of two dimensions that I'd like to talk about with this. One is if the solution to the requirements, if you think that current systems and procedures are fairly effective at dealing with the problem or opportunity at hand, then you probably want to go see how they work, right? So if you go and talk to your users and other stakeholders, and they say, well, you know what we have now, it's about 70% of what we want. Here's what we're missing. Well, then what they have now does, and how it does it, is really important stuff. If, on the other hand, you're talking to these people and they're saying stuff like, this solution that we use doesn't have anything to do with how we should be doing our business. It just holds us back, okay? Well, I'm not saying that you don't want to look at the documentation for it. You might want to look at it, but you certainly don't want to study it forever, because at least the opening position is that it's not solving the problems as they currently exists. The other thing is that there's tons of documentation about systems and organizations and processes and regulations that's inaccurate or out of date, or both. There are some things that were design documents. and they were somebody's point of view long ago that was never realized. Okay, so not only does it not describe the world as it is today, it doesn't describe the world as it was before. It simply describes the world as it might have been in the eyes of some analyst or designer a long time ago. So I think what I usually tell people to do is to make sure that they find out what documentation's out there, because they're probably going to want to take a peek at it, but also get a feeling from people if it's up to date, if they use it, what they use it for, in what ways it's reliable or unreliable, all those kinds of things, so you know how much of your effort to put into it, because it can be time well spent or time completely wasted. A technique that they described in the text that is represented by the slide here is a cultural probe. And it's a really cool idea. You gather data by creating some kind of something for your population to interact with. And it's a pretty cool idea because it can become a learning experience even for the people that you're trying to study, right? So it's a pretty cool idea. Whether you're going to be able to use this in some kind of a systems requirements context, I'm not sure. But it's a very interesting idea. Here's more mainline stuff. Typical ethnographic study work, interviews, usability tests, user participation. This is all stuff we talked about a couple of chapters ago. I mean, here's where you do it. One approach that was talked about in the chapter that's particularly interesting is called Contextual Inquiry. It's an approach to ethnographic study where the user is the expert and the designer becomes the apprentice. So this whole role of the designer as becoming an apprentice is a hallmark of the contextual inquiry approach. It's a form of an interview. So you go out as the designer and you have an interaction with the user. Typically you're going to do it at the user's workplace. Okay, that could be a workstation, that could be an office, whatever. Probably 2 to 3 hours long. And there are 4 main principles that we want to follow: context, partnership, interpretation, and focus. And what do we mean? Well, the context: see the workplace and see what happens, right? The partnership: the user and the developer collaborate. Okay, so you can actually talk about what's going on. You're not worried that your talk with the user is going to somehow color their view. What you want it is to more likely color your view. Okay, but you can ask for a clarification. You can suggest alternative interpretations of what you see, and you see what kind of feedback that you get from your partner. Interpretation: the observations are interpreted by the user and the designer together. Okay, so it really is a partnership all the way down through interpretation. And focus: the project focus is to understand what to look for. Okay, so this is this is a particularly kind of user-involved ethnographic approach. Um, that's pretty cool stuff. Okay, so considerations for data gathering with respect to requirements. Okay, um, have we talked to all the right stakeholders? This is a typical systems analysis, project management kind of stuff. We've got the users, we've got their managers. We probably want to talk to system developers if we're going to expect them to build a solution for us. Representatives, people who work with the customer, um, people who represent the union, people who represent shareholders. Just, stakeholders can run the gamut. Okay? Um, we need to involve the stakeholders appropriately. So, depending on who they are and what they have to offer, we might involve them in workshops, interviews, workplace studies, um, have stakeholders assigned to the design and development team. Um, uh, the next bullet, real users, not managers. I historically, I'd like to characterize what real users, the workers, can offer us as being different from what their managers can. Um, when you talk to the workers, you more typically get an accurate idea of how things work today. Okay? If you talk to their manager, you'll get some kind of idealized view of that. Because typically the workers don't worry the manager with the ugly stuff that goes on. So if they have to kludge things in the system to get things done, and if there are certain outlier cases, a lot of times the managers don't even understand that level of detail. So if you talk to the managers, you won't get it. Okay? Um, on the other hand, managers are better at knowing what the possibilities are. So if you're trying to come up with alternative solutions and you need to know what kind of wiggle room you have in terms of the constraints on the process and the solution, well, the managers are going to have a better idea of that than the workers themselves will. So I think you really need to talk to both. Um, you have to understand the politics and the power within the organization. You have to understand the dominance of certain stakeholders. In particular, I think that the people who are paying for the efforts, um, sometimes referred to as the sponsors, are have a little bit more power and deserve more deference, and are due more deference than the other stakeholders more generally, because they're paying for the party that we're all at. And if they stop paying, then we're all going home. We need to be aware of any changes in the economic or the business environment that are relevant to our circumstances. Um, and we have to keep in mind the need to balance functional demands with usability demands. Okay? Now, I think we would like to claim that you can build a system, you can design a solution that is both highly functional and highly usable. Okay, but of course, if we have a given amount of time and money, we're going to have to consider both, and so we're going to have to share the budget in those endeavors. Requirements management. Okay, so uh, one one part of um, systems analysis and expressing the requirements that's becoming more and more important these days is the idea that as we go along and we express the requirements, however we're going to do it, we're going to use use cases, we're going to use scenarios, we're going to use user stories, okay? Well, they're going to change over time. So, are we going to put them under version control? We probably should. And who's going to have to sign off when those things change? Okay? So the whole change control, version control, current configuration management with respect to requirements is a big issue. And as the organizations get the organization gets bigger, and as the solutions get more complex, well, then the need for a formal approach to requirements management gets higher and higher. We need to make sure that we have healthy communication between all the parties, within people on the design and the development team, between the design and development team and the customer users, between the users. We shouldn't believe that all the people who are going to use a system are homogeneous. Okay, to the extent that we serve multiple user groups, okay, well then we have a bigger solution that it has maybe a bigger impact on our organization. But it gets harder and harder to get consensus about how it should work. Okay, so if we, the one way to deal with this is just to solve a problem for a very few people. Well, that doesn't have a lot of impact. Okay, the other thing we could do would be to solve it for a lot of people. Well, maybe we can't get consensus. So we're looking for some kind of a sweet spot where we're solving the problem for enough people to have a significant impact without involving so many people that we never get done. Domain knowledge is distributed and implicit. Sometimes it's hard to dig it up and it's hard to understand. So particularly when you are coming in as a designer, as an analyst, and you're coming into a whole new work area, okay? There's a whole new vocabulary. There's a whole new world, you know? And it can be very challenging to kind of understand their world. The users have a lot to teach you. Ideally, you have a lot to teach them. If they were completely happy with their world, you probably wouldn't be there. But unless you understand their world, you're not going to make it better. And you always have to worry about the availability of key people in terms of when you need to get the requirements, you need to get the requirements from the right people, and they may have constrained schedules. So what are some of the data gathering guidelines as they apply to requirements gathering? Focus on identifying the stakeholders' needs. Involve all the stakeholder groups. We just don't want to get it from a subset. Again, we need to control the scope of the project so that the number of stakeholder groups that we have to involve is manageable. Involve more than one representative from each stakeholder group because we want to make sure that we're not getting an idiosyncratic view of the world. Okay. Use a combination of the data gathering techniques that we learned about. Support the process with props such as prototypes and task descriptions. Those are good ideas, and I think we've seen examples of that in some of the artwork that we've had in a couple of the chapters that we've recently covered. particularly the kind of props that we could use. Okay, so then we need to do data interpretation and analysis. So again, when we're doing this requirements work, okay, so we gather data and then we have to interpret and analyze it. So how long should we let it sit? Well, no, we should do this pretty soon after we gather the data. This is what we said before. We probably want to make some kind of initial interpretation before deeper analysis to make sure that we at least get our initial impressions. Different approaches emphasize different elements of the problem. So you can have class diagrams, entity relationship diagrams. Typically what I do for my systems analysis students, I have them begin with with use cases, which we're going to talk about in a little bit, that describe how the users use the system. So I have them create use case diagrams. I have them create use case specifications. I have them create activity diagrams, which give a little more detail about the use case, the use cases and their logic. Okay. I have them create entity relationship diagrams to explain the data requirements. Okay. So those are the tools that I prefer to teach with. But there are a variety. There's not just one set. Okay, now just about everybody's approach to expressing requirements, it describes the tasks being done by the users in some way or others. Okay, and in our chapter we talk about 3, and I'm going to add a 4th. Okay. So scenarios are very popular with interaction design folk. It's an informal narrative story. It's simple, natural, personal, and not generalizable. And we'll see an example of a scenario. Use cases are came from object-oriented analysis and design. So the same people who brought us object-oriented system development tools are the people who came up with use cases. They assume that what we're interested in describing is how the users interact with the system to get their job done. And they assume a detailed understanding of the interaction. So use cases are typically more extensive than scenarios, and they're more limited to just what's going on between the users of the system, which they call actors, and the system itself. Okay? So, and we'll see some details on use cases in a minute. And use cases can get a little bit heavyweight, and so some practitioners have boiled down a sort of abstracted version of use cases called essential use cases. And I must admit, I've not used essential use cases myself, although I've seen them a number of times. And they're an interesting idea. Their idea is to be kind of a lightweight, not so detailed version of use cases. And there's a 4th alternative that's not talked about within the chapter, but important to know about. And that is called user stories. And user stories are part of Agile system development. And user stories are, let's see, they're kind of a cross between essential use cases and scenarios. I mean, they're lighter weight than use cases. They're more boiled down than use cases. They have some of the detail that we put into scenarios, and they're just sort of another subgenre. So the general genre here is story-based task descriptions. Okay, they're all based on stories. Okay, all four: scenarios, use cases, essential use cases, and user stories. And they all try to address how is the user getting their job done, okay, and providing information about how the user is going to interact with the system to get their job done. So here's a scenario for the travel organizer, and I'm not going to read this for you, but as you can see, it has a lot of detail about the users. Okay, and as so, it's very much, you could use this, for instance, to extract personas, right? In fact, this is kind of persona plus when you really think about it, because here we're talking about the Thompson family. They're using this travel organizer planning tool, and not only are we identifying individual personas, but we're talking about how they interact with each other and how they interact with the system and how they get a job done as a group. Okay, so that's a pretty detailed scenario. Now, I call it personas plus because you'll notice that in scenarios we identify personas. So how do all these things relate to each other? Well, this is, I think, just the greatest little graphic here on slide number 29, where we have a persona that defines who the story is about, the main character, his or her attitudes, motivations, goals, and pain points. Okay, they want to get to a goal. Okay, so the goal defines what the persona wants or needs to fulfill. The goal is the motivation of why the persona is taking action. When the goal is reached, the scenario ends. And the scenario describes how the persona gets to the goal using our solution. Okay? Pretty cool, huh? Now, here's a typical part of a use case. Now, use cases typically are a combination of use case diagrams and use case specifications, which have a text. So let's look at the diagram first. Here's the diagram. Okay. Typically, you do the diagram before you do the specifications. So here we are looking at one use case diagram for the travel organizer. This might not be all the use cases that make up the system, but they're the ones that we see here. The use cases are on the inside of that box. Okay, they're ellipses, and they have verb, noun, phrase, names. So update travel details, that's a use case. Identify potential vacations, that's a use case. Okay, so this is a part of system functionality. Okay, and it's been bundled up. It's been segregated, so you can see the part of the system that has to do with just that use case. It's a case of using the system to get to a goal, a use case. Okay, so the use cases are in the ellipses. On the outside of the box that we see here is called a boundary box. It's the boundary of the system. So the functionality that's in the system is inside the boundary box. So all those ellipses for the use cases are inside the boundary box. Okay? Well, what's outside of the boundary box? Well, we have these actors. They're the stick figures. And are they always stick figures? Well, they're stickish. Some of the diagrammers will use the images of people that you see on the bathroom doors, on the door of the men's room or the women's room or the inclusive room, although some of the images that we need to put on the inclusive one are sometimes challenging, right? Well, so probably it would have been better to stay away from the bathroom people, given politics as they have evolved. But the Visio diagrammer that I use a lot uses the bathroom people. But here we see the classic stick figure people. Each of those is an actor, okay? And the actor has a name, so we have two actors, travel agent and traveler. And an actor is a role, okay? So it's a role that a user plays and as they interact with the system to get their job done. So they could play the role of travel agent or they could play the role of traveler, okay? And it's also true that we can have actors that are external systems. Sometimes our system interacts with other systems. Well, you might say, well, if it's a system, well, doesn't it have use cases? And I might say, well, it does, but it's not our system, so we don't care. Okay? All we care is how the use cases in our system interact with that system. So we represent an external system as an actor as well. Okay, so that's a use case diagram. Okay, now one of the things that we do is that we define a narrative, sometimes called a flow. It's a flow of events that happen in the use case. Okay, now is that all that we put into a use case specification, just the narrative? Well, we usually have a basic flow, we have alternative flows, and then we have all kinds of other things. We've got another 9 or 10 things that we put into a specification. But here in this chapter, what we're looking at are the narrative flows. The basic flows and the basic flow and the alternatives. So let's back up. And this is the basic flow here on slide 30 for use case, the use case for travel organizer. So a use case specification is typically for just a use case. Okay? Now, the problem that we have here is that this is a write-up that I think talks a lot about different ones. So, okay, the system displays the options. Oh, this is just for visa and vaccination. So this is, the use case would be investigate visa and vaccination requirements. So the system does, the user does, the system does, the user does. Now, because use cases describe how a user interacts with the system to get their job done, and because users and systems interact back and forth, like a ping pong game or a tennis game. Okay, how do they interact? Well, the system does something, the user does something. The system does something, the user does something. So in a narrative flow for a use case, the system does something, the actor does something. The system does something, the actor does something. Now, in a proper use case narrative, okay, we typically, the word system is usually capitalized with a capital S, and it means our system. And instead of saying user, we usually have the actor name. So we would say travel agent, blah, 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 traveler, blah, blah, blah. So it would be a travel agent, system, travel agent, system, traveler, system, traveler, system, travel agent, etc. Okay. Now, what we're not seeing here is some of the patterns that I teach in systems analysis is typically these things begin with some kind of actor action. Okay. Typically, systems that we interact with these days, interactive systems, typically the actor does something to tell the system that it wants to do something. So I would have begun this by saying the traveler signals the system that it wants to investigate visa and vaccination requirements. And then I would say the system displays options for blah, 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 blah. So typically it starts with an actor and then the system. And then usually the last thing that happens is that the system does some final thing. Okay, and that's like terminal condition that makes the actor happy, and that we usually say at the end of a flow, we usually say the use case ends. Okay, so this is an interesting kind of approximation of a basic flow for a use case, but it's not perfect. It would only get about it only get about 60% grade from me, but I'm a stickler. Now, in addition to the basic flow, we have these things we call alternative flows. And this is a really nice thing about the way use cases work. If you go back to the basic flow, it only describes how things work in a normal, successful scenario. And people call this the happy days scenario. They call this the main scenario. They call it the success scenario. It has a lot of names. Okay? So one of the really nice things about these flow narratives is that when you read the basic flow, it reads like a children's book. Nothing ever goes wrong. Everything goes right. It's beautiful. Okay? Well, what happens if we have a more complex world than that? What we do is that once we've described the easy case, the happy days scenario, then we describe these alternative flows. Okay? And here, the system that they use here is that on the basis of the number that they're using, you can tell where they came from. Now, if you take my systems analysis course, for each of the alternative flows, you have to give it a name. You have to explicitly say how it starts. You have to explicitly say how it ends. And it either ends by the use case ending or rejoining the basic flow. But the idea here is that you keep the unusual logic separate from the usual. It makes it really easy for users to understand how your solution is going to get their job done, right? So this would be a typical use case It would have again, it'd probably have another 10 things that you would add in addition to what you see here. And some of the details would be a little tighter, and it would be a use case specification. And I would write one of those for every use case that I have on my diagram. So I'd have one for update travel details. I'd want to have one for retrieve vaccination requirements. Interestingly here, even though they seem to combine them on the previous flow, here they see the vaccination requirements and the visa requirements as two different use cases. So if that were true, they would not have been combined back in the specification. You would have a separate one for each. Okay? Now, what's nice as an interaction designer who wants to come up with a design, you want to create some kind of a prototype, right? Well, you can take a use case, the combination of the diagram and the specification or specifications, okay? Or you can take a scenario that we showed you before we got to use cases, and you can say, okay, let's come up with a prototype that will support that scenario. Okay. One of the nice things about use cases here is that the use cases are fairly narrow. So we have something like retrieve visa requirements. Well, if we have a web application, how many different web pages is that? Well, maybe 2, right? Maybe 3. Maybe you have to show how do I navigate to it, and then 2, what data do I provide to it in some kind of input form, and then 3, what does the report back look like? Okay. Could we mock those up using some kind of prototyping tools? Sure, we could. Okay. Now, if we go back to our scenario and persona, our scenario is not so organized. It's not so divided up as our use case model. So to do those things, well, then how many potential screens would we need to design? Well, 10, 20, 15, something like that. One of the things I like about the use case approach is that the mapping between the use cases and the number of system pieces that we need to design is a little clearer. Okay? So that's use cases. Now, what are essential use cases? Well, they're more boiled down. How does that help us? Well, one of the criticisms of use cases is that there may be too specific about how the users are going to interact with the system, and they constrain the design. So maybe if we just take the essentials and we boil them out, there'll be more latitude for the designer. So here we have an essential use case for retrieve visa, and we have it broken down into user intention and system responsibility. So user intention, find visa requirements; system responsibility, request destination and nationality; user intention, supply required information; system responsibility, obtain appropriate visa, blah, 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 blah. Okay? So it's more boiled down. Okay? I could see doing this Do I know a lot of people who do this? No, I don't personally know a lot of people who do this. Do I know a lot of people who use cases? Yes, I do. What about user stories? User stories are a little bit more boiled down like this. People who are using agile development are using user stories. Um, they're more sort of atomic. They're more disaggregated than those scenarios are. It's less of a big story. It's more individual parts of the story. And I would say that, you could take a user story, and again, you could say, well, how many screens does this turn into? And you could design, you could prototype, you could come up with the prototypes to show how we realize that user story. Okay, so um, going from scenarios, use cases, essential use cases, or user stories, I think probably the most challenging of them is a scenario because it's so aggregated. It's just one big story. The rest of them are kind of disaggregated. The one that is the heaviest weight are the use cases proper. The two that are lighter weight are essential use cases and user stories. And user stories are very popular these days because agile development is very popular. Task analysis is another thing that we could do um, to help to understand the task at hand so we could do the design. So these descriptions are often used to envision new systems or devices. It's mainly used to investigate an existing situation. It's important to not only focus on superficial activities. So we want to be able to answer the questions like, what are people trying to achieve? Why are they trying to achieve it? How are they going about it? There are a number of versions of task analysis. The most popular of these, HTA, is called hierarchical task analysis. And it involves breaking the overall task down into subtasks and then each of those into sub-subtasks and so on. These are grouped as plans which specify how the tasks might be performed in practice. HTA focuses on physical and observable actions, and it includes looking at actions not related to software or interaction with the device. So you can include user actions that are not part of the solution. You can do that in use cases as well. And nothing really says you can't do that in scenarios. You start with the user goal, which is examined, and the main tasks for achieving it are identified, and then we keep breaking down into subtasks and sub-subtasks. So the example from the book that's reproduced here, we want to buy a DVD. I think what's kind of interesting is that when we introduced this this example into the text a number of years ago, DVDs were sort of high technology. DVDs are kind of aging technology now. But that aside, the overall task is 0 in order to buy a DVD, and then the next level down starts with 1 and goes through 5. Locate the DVD, add DVD to shopping basket, enter payment details, complete address, confirm order. And then we have these plans. So these plans are how we would go through the task breakdown in order to get the job done. So if you're a if you're a user who's been to the site before, you do 1, 2, and 5. If you're a new user, you do 1, 2, 3, 4, 5 because you don't have the payment details or the address. I just want to point out that that might not be the only reason why you need to enter the payment details or the address. I mean, you could be a user who's not a new user who wants to charge it to a different card and send it as a gift. So perhaps the new user, regular user distinction is not as accurate a way to describe the requirement as we could have used. And here's just the graphical version of what we saw textually on the last of the slides. So that 0 task is sort of the root node in the hierarchy, and then 1, 2, 5 are immediate children, and they each have their own node. Oh, I'll talk about the summary. Getting requirements right is crucial. Yeah, it's true. There are different kinds of requirement. Each is significant for interaction design. So if we want to be exhaustive here, we want to say that there are 3 kinds. There are functional requirements. What does the system do? There are data requirements. What does the system have to know? And there are non-functional requirements. How does it have to perform? Included in the non-functional requirements are what sort of usability characteristics does it have to exhibit? The most commonly used techniques for data gathering for systems analysis are questionnaires, interviews, focus group, direct observation, studying documentation, and researching similar products. Okay. How do we embody the requirements? Well, we typically describe activities, and we could describe them with scenarios. We could use use cases. We could use essential use cases, and I introduced one that's not in the text, the Agile development-based user stories, which are kind of somewhere between use cases and essential use cases in terms of their size, and maybe have some of the appealing persona-based aspects of the scenarios. And then the last thing that we learned about was task analysis and HTA. So that is it. Okay. Now, do we have to do all this ourselves? Well, if we're working on a project all by ourselves, I guess we do. We're going to have to make sure that we understand the requirements before we do the interaction design. If we're working with a team of people, though, including, say, systems analysts, we may just be one person on a team who's responsible for taking things like use cases or user stories or something like that and coming up with a design that realizes those use cases or user stories, perhaps 2 alternative designs, and then doing some evaluation. Okay, so that's how this all fits. So having said that, I'll say bye until next time. Bye-bye.